Monday mornings are the worst. If you've ever woken up with a hangover, a commute, and 3,000 wasps to classify before your lunch break, and let's face it, haven't we all, then you will surely have wondered, what if there was a better way? Well, finally, there is. Using RoboFlow, human people like you and me can train automatic systems to identify our wasps for us. Keep watching to find out how. I'm Harrison Bumblebee, and welcome to Everyday Ideas for Common Situations. The first thing to do is get your sample images. If you have access to a copious amount of wasps through your work or your school, you can skip this part of the video and go to section 2. Otherwise, you'll need to get out into the field with some wasp traps. I am partial to yellow pan traps myself, because they're cheap, you can 3D print them, and they cause relatively little environmental harm. However, if you've got pitfall traps or malaise traps lying around, those will work just fine, too. Once you have taken your traps in and you've got your dead wasps, I would head on over to your lab, chuck the wasps in a petri dish, and then take a photo of them through a microscopic lens. If you don't have access to a lab, don't worry. The equipment is completely affordable for the everyday person. It's only $8 for a pack of 20 petri dishes, so you can buy a couple, that's not so bad. And I found this microscope on Trade Me for a reasonable $164. Make sure that the entire wasp is visible in each photo you take, and minimize any background debris or viscera. You don't want your AI to start learning about viscera rather than wasps. I would aim to get a collection of at least 50 wasps, and the more the merrier. If you can get a data set of 500, 1,000, that's great, that's amazing. For this video, I'll be using a sample set of just 20 photos, but keep in mind that I may suffer some unreliability as a result of my low sample size. Once you have a folder of your photos, it's time to move to RoboFlow. The website you're going to want to go to is app.roboflow.com. It'll come up when you search it into Google. When there, make an account and then click New Workspace, and you'll end up on a page that looks like this. So I have a few workspaces that I'm being invited to join. Eye Cancer Data, B Faces, E-Scooter, and Cone Detect. These are some of the many powers of RoboFlow. It can check eyes for cancer, check Bs for faces, and check scooters for E's. But today, we're going to learn how to make our own workspace for wasp identification. So you're going to want to come down to the bottom and click Create My Own Workspace. Once you've done that, it will ask you to name your workspace. I'm going to call this workspace Wasps for YouTube. And it's going to ask you if you want a starter trial or a public plan. The downside of the public plan is that your model will be open source. So anybody will be able to access your data, see what you're doing, and join in. You also won't be able to deploy it commercially. So if you've got a business you're trying to start up based on wasps, you will need to buy the full license. The upside of the public plan is that you don't have to pay $270 a month for access to RoboFlow. And that's quite good because $270 a month is quite a lot of money. You could buy 1.5 microscopes with that every month, which would mean you'd come out of the year with 18 microscopes. Or you could have RoboFlow for a year. I think the public plan is better bang for your buck. If RoboFlow wants to sponsor me, I will gladly recant shamelessly and sell out and say you should probably spend 200. You should probably send us, like, you know, rather than maybe groceries for a week. Why don't you buy RoboFlow and then just go hungry for a week, and then create a public plan, and then it will ask you if you want to invite teammates. You only get to invite 2 people on the public plan, but if you have friends, you can invite them and they can join your work. I'm just going to continue without adding others. Cool. It will do a little configuration. So now we have our workspace, and you'll be greeted with these tabs on the left. We have projects, workflows, monitoring, notifications, and settings. What we're going to want to do is go into projects and click New Project. When you click New Project, you'll be greeted with this screen. It's going to ask for a project name, visibility, annotation group, and a project type. Name it whatever you like. I'm going to call this Wasps for YouTube. Visibility, you can put it on whatever you like. And then annotation group is what you're classifying. So here, what we want to classify are the different types of wasp. So maybe we want to know if it's a diapriid, or if it's a... So what we want to know is it a diapriid, is it a ichneummonid, or is it a chalcidoid? So I'll put diapriid in as my starting object group. Cool. And then we choose our model. So the different models have different functions. In this video, I'll be showing you guys how to use the object detection model. This is a simple model where we're going to draw a boundary around an object. But the other ones are interesting. Classification will be just labeling the entire image, which can be good if you just want to quickly go through, is it a wasp, not a wasp? But here we also want to get a boundary, and so we're going to do object detection. If we had parts of a wasp that we were labeling, like antenna, mandible, ovipositor, then we could do instance segmentation. And then multimodal is for text-image pairs, and I don't know what key point detection is. I don't get it. I think it's for like morphological, how is this being operating in space? We're concerned with object detection. So let's click object detection and then click create private project. Okay, now we get greeted with this screen where we're being asked to upload some files. All you have to do is click select files, go to the folder where your wasps are. I've got a few different wasp folders. I'm going to go to RoboFlow video, and here are my wasps. Now you should ideally aim to have more than this, but I don't want to spend all day labeling wasps for the video, so we're going to work with 20. Select all your photos, click open, and RoboFlow will process them. Click save and continue once you're ready, and wait for the upload to finish. You can play some elevator music, maybe some heavy metal, whatever you like, while we wait for the wasps to be done. And now, once you're done, you'll get a question that will ask you whether you want to auto-label, manual label, or RoboFlow label. For this kind of work, we want to manually label the wasps. Auto-label is a beta feature. We want to do it ourselves for reliability. We don't want to pay an actual RoboFlow team member to do it for us. So we're going to click Start Manual Labeling on the right-hand side. If you have teammates, you can delegate, spread out your wasp photos amongst the teammates. I just have myself, so I'm just going to click Assign to myself, and voila! We are greeted with the annotation screen. With that, RoboFlow is set up and ready for action. All that remains to do is to annotate the wasps and run the model. Let's see how we do that. You want to come to the annotations box and click Start Annotating. You'll get a summary of all your pictures. Just click Start Annotating in the top right corner, and you'll be greeted by a photo of your very first wasp. On the right hand side, you'll see the various tools that RoboFlow has available. The drag tool just moves the image around, and if you've drawn a label, you can move the label around the image. The bounding box tool lets you draw a box over the image and then assign it to a specific type of organism. So okay, we could draw a rectangular box around the diapriid, but we can do a bit better than that. We want to come down to the Smart Polygon AI labeling tool. On the right hand side, it's the fourth icon down. It looks like a glowing mouse cursor, like a mouse cursor imbued with arcane power. We click that, we click standard because we don't have premium, and then if we click on a part of the wasp photo, it will draw a nice polygon around the wasp. You can see it's chosen the wings and kind of separated the wings out. Now we don't want just the wings, we want the whole wasp. So if we've clicked on the wings, we want to click on the body too, or grab the body. And then we want to try to get the other parts. So we want to get some leg. Legs are important. And we want to get both antenna. And it's very important to get both antenna. They're a bit annoying to get sometimes because they're long and thin, so the AI doesn't grip them as tightly as maybe you'd like. But with enough clicking, you will get there, like so. Now, the only thing to note is, up here, in the top left, we have the Smart Polygon box, where we can go from complex, where it will draw like a really tight contour around the wasp, to simple, where you're going to get a basic polygon. There's a trade-off here. If you have a really powerful computer, you can go complex, you'll get a really, really nice fit, but the cost is, it's going to need a lot of processing power, because this is a much more complicated polygon. Whereas, if we come down to a simple polygon, although it's rough, it still generally contains the wasp, and you're able to process it easier. I just use simple myself, because I'm just an everyday person in a usual scenario. So I think simple is good. You want to minimize the computational load, but if you are doing really, really high-tech stuff and you need the precise polygon detection, then go for it. But you are going to need a really good computer. So, with that done, we click Finish. Now, the final thing we have to do is label it. So this is the part where you enter the kind of wasp it is. Now, this is a difficult photo, but if you look at the wasp's head just at the base of the antenna, you can see a slightly protruding shelfy bit, which is indicative of a diapryid. Diapryids are the most common wasps that you'll find in traps, at least around New Zealand. So it's no surprise that we'd get a diapryid. But usually you want to look at them side on because the shelf is really visible. In this photo, you can hardly see it. I mean, if you told me this was an ectomonid, I would believe you, but I'm pretty sure it's a diapryid. So we're going to type diapryid into the labeler box, like so. Click Save, and now, when we hover over the polygon with our drag tool, we can see it says diapryid. Amazing. Perfect. Okay, so that's one wasp. We've got 20 to do. Critical warning. Occasionally, when drawing polygons around diapryid wasps, you may find the time slipping away. You may find night overtaking the day, and you may find yourself beginning to fade. Or you may just end up with 20 labeled polygons of wasp. Amazing. We're done. We've succeeded. Amazing. You've done it. All you need to do now is add the images to your dataset by clicking this purple button in the top right hand corner. What you'll see is it's going to split the images between a training dataset, a validation dataset, and a test dataset. So what's going to happen is we're going to give the training images to the computer along with the labels we provided, and it's going to learn what they are, what their characteristics are, and then we'll give it the test data without labels, and it will have to label it, and we'll see how accurate it is. If it's accurate, amazing. We can feed it more pictures of wasps, and it will accurately tell us what they are without us having to look at them, which is a solution to a critical everyday problem, or an every night problem. So here's our data set. We have some purple training photos, some blue validation photos, and some orange test photos. And all we have to do now is train a model by clicking the train a model button. So we click this, we will give it our source images and the training test split. And we have the option to pre-process the images in different ways. I'm just going to use the defaults, auto-orient and resize, but there are additional steps you can experiment with yourself based on how you're feeling and what kind of dance moves you want your wasps to do. Once you've decided on your pre-processing, you come to the augmentation. Now what this is going to do is distort your images in different ways to force the model to try to come to grips with your images even when they're not clear and easy to look at like you might want. So we can click Add Augmentation step, we can do rotations, brightness changes, hue changes, we can arrange them in a mosaic in different patterns. I think I want some rotation, please. This is good for if you're using like random cameras to get your pictures, so you can't guarantee that they'll be at the right angle. This will randomly rotate the wasps by a set of degrees that we can specify. I'll specify 15% and apply it. Cool. And we can click continue. And now the final step is to create. So we can, if we want, have it generate way more images. It'll keep making more and more variations of our photos using the augmentations provided. The really high numbers require premium. We have to spend, again, $300 a month. So we're not going to do that. We'll stick to 3 times, which is a good number for this test set. But for the purposes of demonstration, this will do. So we click create and let it run. There it goes. The machines are at work behind the scenes. Who knows what they're doing? Could be anything at all. Could be nothing. Or it could be critical work. And finally, you will get a version with all of your data in the right place at the right time. And you can either custom train it with your own AI model or train it with RoboFlow. You get a limited number of RoboFlow credits, so I wouldn't recommend using them frivolously on things like demonstration YouTube videos. But I don't have a custom model on me, so what I'm going to do is use my credit for frivolously and train with RoboFlow. So I'll click the big purple button. It's going to load some model checkpoints. You can see there are 3 models available to me. There's RoboFlow 3.0, there's You Only Live Once version 11, and there's You Only Live Once dash Not Again Sister. For my purposes, I'm going to go with RoboFlow 3.0. So I'm going to click continue. And I'm going to have the option to choose between fast and accurate. I think accuracy is usually good. It's usually worth taking a bit more time to get better data. But for the purposes of this video, I'll go with the fast option. For you, choose which one suits you. If you have a deadline, like you need to get your wasps in by 3 p.m. and it's 2:30, and if you don't get them in, you're fired. Like, use the fast model by all means. Otherwise, accuracy is important. But I'm going to click fast. So we click continue. So we now have the option to train from a previous checkpoint or a public checkpoint. I'm just going to go with the default here, Microsoft Cocoa. I think that you may as well. You can see there's an option to train from random initialization, but it's just worse than using a public checkpoint. So let's just not tinker with anything, click start training, and let it go. And there you have it, all done. What will happen next is you'll get a notification from the RoboFlow team saying your model is being trained. We expect it to take this long, and we'll send you an email when it's done. So yeah, based on the size of your dataset, that could be not very long, or it could be ages. For me, it says 41 minutes, but as you can see, it's my bedtime. It's dire outside. So I'm going to go to bed and hopefully wake up in the morning where we can see what the results are of all of this stuff that we have done. See you then. And at last, here are the results. So we can see up in the top right hand corner, there are 3 scores we're being given: MAP, precision, and recall. They're all measurements of how good our model is at predicting what kind of wasp it's looking at. We can also have a look at individual images, so we can see the model predicts with 88% certainty that this is a braconid wasp. This one it believes is a braconid with 85% certainty. That's definitely a braconid. Absolutely. This one it predicts to be Mimaridae with 85% certainty. I'm not convinced that's a Mimarid. I think it's right. I am also about 85% certain that's a Mimarid. It could be a Chalcidoid. Mimarids typically have long, like, fan things on the edge of their wings. This one's got very blurry wings in the picture, so I can't tell. This one, it thinks, is a Chalcidoid with 87% accuracy. That's not a Chalcidoid, though I'm 97% sure that's a Platygastrid, because look at that flattened abdomen. So yeah, you can explore your model. You can see what it does. You are also able to deploy it. If you have somewhere you want to put it, you can upload it to the cloud. You can deploy it onto your device. So all in all, you can use RoboFlow to take a bunch of photos of wasps. You can photograph other things too, but I would recommend wasps because wasps are the most commonly used thing in life. And you can train models to automatically ID them. Now, there's many different kinds of model. There's lots of different augmentations you can apply to your model to fine-tune it to get it really perfect. This is just a test model, so there's a lot of work to be done to make it really good at IDing wasps. But now you know the process, you can go in and try for yourself. Go tinker around, take some photos, put them through RoboFlow, and see what comes out the other end. I, for one, am very, very excited to make use of my new wasp identifying powers. Thank you so much for watching, everybody. I'm Henrietta Brainworm, and this has been Everyday Skills for Usual Situations. I'll see you all in the next one.